PSN College of Engineering and Technology in Tirunelveli. We are today talking about robotics and mechanical actuation. This subject is very interesting subject. It's just wonderful one when it comes to wonderful is and implementation, new type of robotics and everything. Okay, and this is a chapter syllabus. Okay, introduction to robotics. We talk about introduction, automation, robotics, brief history of robotics, and the concept of robotics, and three types of robotics, and etc. And secondly, we will discuss about grips, sensors for the robotics. Third unit we will discuss about drives and controls for the robotics, and fourth unit we will discuss about different types of programming language which are used for creating robots and how can we control them, everything. And fifth unit we will discover unwanted aerial vehicle machines like UAV, something like that, which is made for have several applications in robotics and several implementation to control the UAV. This is a manual, something like that. Okay. So let's focus on. So what is robotics? It's a programming machine capable of performing a specific tasks, like a pick and place robots or something like that. And it can be very from fully controlled by humans, like a robot which can be used for detaching the bomb or bomb squad robots, and some robots can and rover something like that, which fully controlled by humans. It's not very personal. Some are there is minimal external involved, like starting off buttons, like in several factories we are using big and complex robot, which is like we fully programmed them from the beginning, and now we need it's need small human handling for that. Okay. Now next one is let's focus on this topic is we focus on design, construction, operating, and application of several robots and platform tasks they are handling. Okay. Key fields such as mechanical theory, you have to structural design, structural analysis, kinematic dynamics analysis on them. Electrical, we have to make a motors, actuators, and sensor decision, and then comes to computer science. We have to create control algorithm, programming, artificial intelligence, AI, and machine learning. Okay, we are going to talk about division. When it comes to industrial robot, a programming manipulator is designed to move a material parts to tools or a specific device through variable program and motions for a performer a variety of tasks. Like I'm not going to talk about it's a robot, which is we are programmed to manipulate at a specific direction or specific motions in which it can move the material parts, it can do with the tools to create some wonderful things, something like that. Okay, there's another thing is programmable. Sometimes some devices come with pre-programmed, we cannot change. Here some robots are we can change by each and every time we can re-change by erase the memory and input the new program and insert the memory card to the robot. The robot will be adapted to new motions, like 3D printing machines or laser cutting machines. These are the robots where we can use the reprogrammable memory card to change their way of motions to way of tools motion to create a wonderful things. And scope of robotics. Scope of robotics, it's several scopes like medical, surgical automation, space for rover and things making. In agriculture, we can make for indoor plant decisions and for UAV, automated vehicles, car motions, and several industry we can use. Nowadays, most of the industries are using robotics to create faster, errorless, and very cheap product at very low cost. Okay, and so something like that, something like this very useful useful for several industry and several applications. And build some kind of well education with free applications and also removal like bomb scope. We have to use the robots to scan a area like a drone. Sometimes military people use drone to bomb a particular area, something like that. And hazard environment is like toxic environment, like a bomb leak or toxic gas leak, something like that. We can use a rover or robots to rescue humans, something like that. In military, there are another application of bomb scope. These several robots are handled by humans to diffuse any kind of bombs or something like that. Okay. Why study robotics? For academic industry, it's the future. Nowadays, the AI is implementation, so this way we can make several different robots and complication program to create wonderful things too. Like facial expression can be easily done by robots with the help of AIs, and we can make IoT and several research path applications. Several application can be, the door is open, the world is open for you. We can create wonderful things. Maybe I saw a movie in which a robot learned to how to pray, he turned to a Buddhist, something like that. So there's a numerous application for robotics. So if we learn that, we can make them. We can make your home. Maybe we can make your home with wonderful things like that. Several wonderful things can be done by the robotics. Okay. Core components of a robotic system: a manipulator, interpreter, sensor, actuator, controller, power supply. Manipulator is amps or something like that, which can just a structure which movement can be based, right? It can move around like this place is mostly to move the things. Which interpreter means it has the gripper at the end of the finger of the robot. It attached and it help it to hold or grab anything. Maybe it can use a tooling device to work. Maybe it's like welding machine or something at the end of it. Maybe fulfill the program, something like that. Sensors is like it's the eyes and ears of a robots. Sensors will send something, sends this information to the board, and board will analysis and it will make a decision based on this, and it will do it like listen, decision making, implementation. So first the listening, for we need sensors. Maybe sensors can be two types, inside and outside. For inside sensors means mostly it will sense how the robot is working, the temperature inside the robots, and any problems can be detected. Like mostly inside the car to check the oil level, petrol level, engine registration, something like that. Same here, we are using sensors to inside the engine, mostly for sensing inside the robots, to find any fault. Outside sensor for detecting objects and temperature from the outside, any problem, something like that, it can detect. Actuator is like three types. One is electric and pneumatic, hydraulics. Okay, these actuator will provide you motions to the system. Like electrical actuator means it will like mostly like you use motors. Pneumatic means we use air to pump and air to lift these things. Pneumatic very fast, but it can really lift very small amount, smart, right? Hydraulic, when it comes to it, can done the work. Heavy duty work we can done by hydraulics actuators. But hydraulic actuators have a problem that it can, after several years, it can be oil leak can be happen. Okay, controller, it's the brain of the It have the programming, right? It will process the feedback and everything, like from the sensors, actuators, everything, and it will make the watch do the power supply means it's a source of energy, like battery, grids, and everything. Okay. This is a and more diagram in which we can see that just show you through this simple diagram: power supply, interpreter, actuators, communication interface, camera, camera, sensors, and mostly we use proximity sensor in every program, every robotics, everyone. Like proximity sensor is a commonly used sensor. Like in your mobile phone, you can see that when you call anyone and put your phone near to your ears, and you can see that the light of the phone will turn off. The proximity sensor, it will sense something when comes under its proximity. Like it can detect things, presence or absence of anything can be detected by proximity sensor. So some people use proximity sensors for the jewelry shop to sense if something is missing, it will detect, it will put an alarm. So it can use for detecting things or absence of anything. Like there are several types of proximity sensor available nowadays, like magnetic, battery, something like that. But we use this is commonly used proximity sensors. Approximately cost of 200% Amazon. We can Google it, maybe use the Arduino unit, we can get wonderful project with proximity sensor. Most of the engineers use proximity sensor to build things. Okay, now we go back to our major topic. Okay, this is another diagram. We can see that in here we can see that power unit, controller, system, mechanical structures, internal sensor, external sensor. Okay, this is also the same diagram. Okay. We can see the controller. Controller have a on off switch with it. Each can vary from different to maybe it have a display or something like that. Several buttons to control more motion, something like that. Okay. This one here you can see we create a program, insert controller. Controller will go to the help with the help of the power unit. The mechanic structure will move the robotic. In here we can see the arm. This is where the grip to hold or do the work. Okay. So I will tell you with the computer in where we insert or create a program. This program will go to controller. Controller will make the decision to how to do the work. With the help of the power unit, we will move the actuator, will move this robot, and the robotic arm will move around and will be done by the actuator to grab or hold something like key. Industrial robots, service robots, medical robots, exploring robots, humanoid robots, civil robots, something like that. This is a more robotic application we are using robotics. Okay. Automation of robotics. Sometimes automation, it's a modern manufacturing industrial application. Like industry, we are using automation to create robotics nature to do the work, like bottle filling robots or scanning robots, something like this will come and scan everything in go away. So it's automatic motion robots. Also there is a mechanical motion also there, which will be more humans. And here you can see the fully automated, semi-automated, manual. Manual control means a operator means human leader. Semi-automated means if we use sensor PLC to control system, can make things wonderful. Okay, fully automated robotics is with AI-driven adaptive. Then sensings like a Tesla car, it can sense things, it can do the work. Automation algorithms. So automation is a technology that has no human interference, and it's a pre-programmed the robots and it can run the bugs. It is like PLC scanner, ELC software system. Those can be used. It's a fixed bug, it's not driving. and easy to adapt to the flexibility. When it comes to robot, we can easily adapt it to the arms. We can easily flexible when it comes to programming. When it comes to robotic, it's a very range of variety application. We can easily move around, fix one place to another place, and we can do more works from when it comes to robotics. Actually, automation can break fixed works. And okay, type of automation we already talked about. Flexible automation programming. Flexible means fixed means you can do for one fixed work. When you look code, it's like one or two words can be done. Programming we can change the program and change the way of next one, like CNC machine, building like several machines can be done with it. Flexible automation every time we can change highly robotic active. Some we are focusing on the robotic drive system. This is something we are very interesting thing. Okay, drives and control for the robots. Like next we have to focus on the types of drives. Okay, a drive system is connected to control the output of mechanical elements of a robot. Responsible, like this is a way of robot to work. It has three things like electrical, hydraulic, and pneumatic energy. This energy will convert to make the mechanical movement. And this system, the line sometimes is a torque, velocity, and position of the robot joint, enabled to do some kind of motions in the linear rotating motions. And this motion will do up to 2 hours. Okay. And drive system components like also actuator, transmission, okay. Also just these things we have a energy source, like take the pneumatic hydraulic system. These three are different sources, but mostly nowadays everyone use electric sources to supply and all of this kind of energies. Actuators is convert this energy into motion. We are ordered to the basics of the robotic parts. Okay. Transmission means this transmission one energy from another motion. Like the fan will have any motion. Yeah, PS system will convert the motion to another shape. So basically this will help to run the job. Types of electronic drives we will again using drives, transmission, and converting energy in mechanical manual and actuator to its performance. Drive system classified based on the nature of energy used in the actuator motion. Electric drive system. Okay. This electric drive system electromagnetic motors are used to like DC stepper motors or motors who study more basic engineering and controlling. Okay. These motions are generated rotating the motion to actuate the robot joints. Types of electric motors: DC motor, single control, suitable continuous motor, rotation, servo motors, closed loop control, precise motion, and speed and torques. Stepper motor is all. Disadvantage: clear high protection error, accuracy, repeatability, energy efficiency, and compact design, low luminosity, clear pressure. Like here, the pneumatic will have make noise. When it comes to electrical, this will have less noise. Sometimes it's like a fan. So sometimes I do make something we use some kind of dropper system to make it very less noise. Okay. There are several classes out there. And it's easy to run. The limit is low force capacity. terminal continues or high. If you work for the system for 10 by hours, it will heat produce. If you continuously work a electric system, it will produce too much heat. And too much heat can be reduce its efficiency. That can be problem. But some nowadays people are using coolant to liquefy to make sure it's under the cooler and the room temperature will be lower so that this kind of heater can be controlled. Application processes accessibility like packing, laser cutting, robot arm. It's a fastest way to use hydraulic. Now we have to remember hydraulic system. Hydraulic is pressurized incompressible like something to produce water may actually be used which is considered use purpose to be a pump to valves to a hydraulic actuator. This generates a linear or rotary motion. Moment like hydraulic pump, reservoir, valves, or pipes, hydraulic cylinders, motion motors, application form now the robots used to a task in forging and construction. It can lift huge weights. But only problem is it can leak sometimes. So after several heats, the oil will be weak and the efficiency of the material will be chemicals. Sometimes longer period it's not so. People will say that hydraulic after several years, we have years of age. After years, we will have to replace. And usually, we have to replace the oil, check the oil or something like that. Because it can be dangerous sometimes. There was an accident being reported because of due to the lack of oils or the hydraulic can cause accidents. This you can see here that this is a motor and very good here. This is a control valve. This door filter the everything is going to here for you and will be protected from here. Okay, something like that. To hydraulic pump, it's converting energy to hydraulic energy to also from the reservoir to pressurize it. Okay, some more this is the top right. So you can see that everything detail right from this, this table. Just go through it, you will get an idea of how this machine will run. So, motor is on, just where oil will operate, this filter will control it, and this go to here, where this one, then it's replaced, this go to operators. Okay. This is an example. Pressure is controlled. And fluid failure, this valve will go upward, backward motion, simple as that. Advantage reduce kerosene, high accuracy, better response or more than high excellent for heavy duty and larger robots. Heavy duty larger robots we use hydraulic. And disadvantages, like I said, we need maintenance, more expensive to use, suitable clean air and temperature compressor motors. So it's a more system to run it. So due to that, it's need more floor space, right? Not like it's not need to. It's hydraulic need to store it. So that purpose it's need larger. So that is something it's smart for technically you can go to very small sense range of variety can be produced because of the electricity magnet that can when it comes to hydraulic braking system you have to store it. So storage will get space. This is major disadvantage of hydraulics. Pneumatic means here. Pneumatic, you may say that, just say that. Compared to this is air system. Pneumatic drives utilize compressed air stored in the tanks and are directed to the valves to the actuator. Usually, to do the linear fast, maybe linear rotation or something. It's like air compressor valve pneumatic service. Advantage is lightweight, cost efficiency, simple design, fast adjustments, clean and safe for hazard environments. Something which is very low accuracy and repeatability, suitable pressure friction, limited force capacity. Like cannot lift huge weights. It is faster, but you cannot lift huge weights. Sometimes we use several motions in that, but it have a very weight. Used to pick and place robots, stamping, packing, and basic automation. This is here you can see. This is intake valve. Intake valve will be inside the air. This is a compressor. The motor is not on compressor will absorb more air. This air will go to cooler. The compressor air will have this heater due to the friction. This cooler will control it. Separator. Separator will be keeping the waste from the atmosphere have some kind of dust particles get inside. So this separator will be filtered like a bike filter. Like a filter, this will act as like a filter and remove the unwanted, and this will store it. This thing will store it and make a compression or pressure on set it. If it's other than pressure, it goes to secondary treatment, and this goes here. And the controller, we have to open it off it. Right? If it's open, the air will go here. The air will, because of in this number of air, this piston will go forward. And we control about this air will be free and the air and the air will be increasing. So piston go back. It's very simple, right? For weight range motion, we will open this one, there will be here, and piston will go forward. If we can increase here, there will be increase this side, the piston will go inside. So sometimes we use spring motion so that this air will be pushed to this position. When the air is released, the piston automatically go back. This is I'm talking about. This is another method. So here is pushing this piston to forward motion, after release it will come back. It's a good accuracy, excellent speed, easy to install, small leakage can be provided. Even if the air is leak from here, it can cause element like that. In hydraulic, small leakage can be made to run the material very dangerous. But when here, even when a small air is have a leakage, so it's not causes any damages. It's very simple. Here is here. And but sometimes this is very difficult to control. Air needle and need to absorb, and plus precious electric drives, vibration can be due to vibration. It's a kind of more process. The Indian valve is very huge, that makes huge noise to produce because of the friction there cause, and the vibration will be caused disturbance for a very long. These are the timetable in which we have discussed about everything. We have something like also just to go through it only. Maybe if you want to get a screenshot of it, to just read it, this will give you an idea of how it works. Please read it.